In this video, we will look at statistics that analyze relationship. Relationship between variables can be described using 5 features: form, direction, strength, outliers, and context. For example, this chart represents relationship between BMI and time spent on exercise. This relationship appears to be linear. This is related to form. The relationship between BMI and time spent on exercise appears to be negative. When time increases, BMI reduces. This is related to direction. This relationship between BMI and time spent on exercise appears to be strong, and this is the strength. There doesn't appear to be any data points that are unusually far away from general pattern. We say this data set does not have an outlier. This is an outlier. Students can practice these 5 features using the other 2 charts. Today, we will focus on the strength. Strength of a relationship can be measured by correlation. Correlation measures the strength of association between variables. Here is an example. This data set contains 4 data points. If we just eyeball them, they appear to fit a linear relationship. How well do they fit a linear relationship? This can be measured by correlation coefficient. Correlation coefficient can be determined by this formula. N represents number of data points. SI, YI represent each data point. X bar, Y bar represent sample mean of X and Y respectively. SX and SY represent sample standard deviation of X and Y respectively. I already did the calculation and the result is 0.946. What does that mean? When R is between 0.8 and 1, it indicates a very high correlation. When R is between 0.6 and 0.8, it is a high correlation. When R becomes smaller, the correlation becomes weaker. The same rule applies to negative correlation. This data represent relationship between HbA1c level and the fasting blood glucose level. If we just eyeball it, it seems these data points can be fit by a straight line. How do we describe this line? And this task is called a regression. In general, a line can be described by an equation. Here, A is constant, B is regression coefficient. Since this line is straight, this regression is called linear regression. Suppose we have done the work and determined A and B for this regression. Here, 3.2 is the constant, and 0.45 is the regression coefficient. Finally, we will look at statistics that analyze clinical investigations. First, let's look at molecular-based tests used to diagnose COVID-19 infection. Here are the results. First column represent test results. Second and third column represent infection status. 87 people were infected by the virus and were tested positive, and these people are called true positive. 81 people were not infected and were tested negative. They are called true negative. The other two corners are false results. In this case, here, this is false negative, and this is false positive. Sensitivity tells how well a test pick up true positive. We use this formula. So in this case, 87 are true positive plus 3 false negative, and this is sensitivity. Specificity tells how well a test pick up true negative. We use this formula. In this case, true negative 81 divided by this represents specificity. On the other hand, if a person is tested positive, how likely the person is truly infected by the virus? We can use positive predictive value to answer that question. PPV can be calculated using this formula. True positive divided by true positive plus false positive. In this case, is 87 divided by 87 plus 1. If a person is tested negative, how likely that person is not infected by the virus? We can address that question using negative predictive value. NPV can be calculated using this formula. In this case, true negative is 81 divided by false negative 3 plus 81.